Hey everyone, last video I'm going to have here for a little bit on friction, but there are a lot of other kinds of friction that we haven't talked about. We're going to talk about wedge friction here. I haven't even gone into any kind of bearings or screws, which are actually modified wedges in that aspect, or like a clutch situation. There's a lot of other kinds of friction that we could be talking about in this section, but we're gonna stop with wedge friction. So here's just a real quick example. I might have some sort of a crate here that I want to move across the floor here to the right, and it's too much for me to move, but I can set up a wedge situation in here, and I can apply a force F on this wedge here. You know, maybe I'm hitting that with a hammer or something, and that will get this crate moving. And so what we want to look at are the various forces acting on these two pieces. I'm going to assume that there's some angle theta here. They might be different angle thetas, but I'll leave them at the same just for the sake of simplicity. And I really just want to look at the forces acting on these wedges. So I've got the first wedge here, then the second wedge up here, then the crate finally over here. So I apply this force downward, right? There's some force F, that's my applied force. But there's also going to be, I'm actually going to ignore the normal or the weights of these two wedges at this point in time. I'm going to assume that's insignificant when compared with that force F. But there's going to be some other forces. So this thing wants to go down. So there's going to be a frictional force up. I'll call that F1. There's going to be a normal force over here. I'm going to label that N1. That's trying to slide down, so the frictional force is going to be up. It's trying to slide down into the left here, so it's going to be, there's going to be another frictional force here. I'm going to call that F2. There's going to be another normal force here. I'm going to call that N2. And I think that's it. If I ignore the weight, you know, we could put the weight in here with F if you so desire. Just F would be the applied force plus whatever the weight, but kind of leave that alone. Okay, so frictional force due to the wall acting on wedge 1, normal force due to the wall acting on wedge 1, frictional force due to wedge 2 acting on wedge 1, normal force due to wedge 2 acting on wedge 1. That's important because I now have Newton's third law. So normal force due to wedge 2 acting on wedge 1 means there must be a normal force due to wedge 1 acting on wedge 2. Equal force, opposite in direction, up and to the left, down and to the right. Up and to the right, force 2, frictional force 2, frictional force due to wedge 2 acting on wedge 1 means there has to be an opposite, equal and opposite force due to wedge 1 acting on wedge 2. And so that's going to be in that direction. Okay, and so this normal force is going to be pushing in this direction. So there's going to be another normal force acting on this. And we're going to call that N3. That's a normal force due to the crate acting on wedge 2. So there must be a normal force due to wedge 2 acting on the crate. And that's going to be in this direction, N3. We will ignore the frictional force here against the ground. We don't have to. We could assume that normal force, and you know, I'm going to put, I'm just going to call that N4 and F4, frictional forces. They could be there, but they might not be, right? It's just going to depend on whether or not this is in contact with the ground, right? So I can make my life really nice and simple by assuming that it's not in contact with the ground. And why would I do that? Well, that would eliminate some of the friction that might be in here as well, right? So that might make this problem a little bit easier, make the situation a little easier, less force required to get everything moving if that's not in contact with the ground. But if it is, that's okay. All right, and then what am I going to have here? I'm going to have the weight of the crate. And then, of course, there's a frictional force. I'm going to put FC for the force of the frictional force due to the ground acting on the crate. And, of course, there's going to be a normal force. And 5, that's due to the ground acting on the crate. And so we can begin to solve this system of equations and figure out what kind of a force I can give using F, what kind of a force can I eventually get over here at N3? And these angles are all going to come into play. Right? But these are the force diagrams. The rest of that's going to be trigonometry and algebra, and I think you're good with that. All right, if you have any questions on this problem, leave please in the comments below. Thank you.